In this problem, we're going to determine whether or not an order is safe. We are told an 8-kilogram child is ordered to receive the cefotaxime 300 milligrams via IV every 6 hours. The recommended dosage is 100 to 200 milligrams per kilogram per day. Is this ordered dose appropriate for this patient? Before I get into the calculations, I want to just give you a quick overview and a few pointers here of how to approach this problem. When we see a recommended dosage, and that dosage contains a particular unit per kilogram, this is going to be what I typically refer to as that's not customized. That's not customized for our patient. This per kilogram allows us to take this calculation and convert it and to customize it for any size. So we could customize it for an 8-kilogram child like we're about to do. We could also do it for a 20-kilogram child, or as much really as we want. It just allows us to have this one particular instruction on the bottle, as opposed to having, for an 8-kilogram child, give this. For a 10-kilogram child, give this. So what we want to do, and what I typically refer to as customize, we want to take this safe dosage range and we want to customize it for our patient. So our minimum, the minimum, which I'll write over here, is going to be 100 milligrams, and that's going to be per kilogram per day. Right? So this is the minimum safe here, the recommended is 100 milligrams per kilogram per day, and then down below I'm going to write the max. The max is 200 milligrams per kilogram per day. So when you see this per kilogram, the first thing we want to consider is, how can I get rid of it? How can I customize it for the patient, the particular patient that we're referring to? Well, we can customize it by canceling it out. In other words, if I can just take this 100 milligrams per kilogram for every kilogram per day and multiply by the child's weight in kilograms, then the kilograms would cancel. So if I take 8 kilograms, using dimensional analysis here, I'm multiplying by 8 kilograms. If I were to stop right now, I would have, if I multiply the numerators here, I would have 800 milligrams per day. Right? And I'm just going to focus on the minimum, and then we'll go down and do the maximum as well. What this is telling me is, for this particular patient, for a child weighing 8 kilograms, the minimum recommended amount is 800 milligrams every single day. So the most common misconception here, mathematically speaking, and just thinking about the information that's in this problem, a student might look at this and say, well, the child is supposed to receive 300. 300 is a lot. It's quite below that 800 milligrams. So maybe we would go and double check. The problem here is that this 300 milligrams is for every single dose. This is 300 milligrams that the patient is receiving per dose. This 800 milligrams is an 800 milligrams per day. So we have to think about, well, if this is spread out throughout the entire day, we need to cancel out day. We need to break this into a certain amount of doses. So if you think about it, if we're giving every 6 hours is going to be, if we break up our 24-hour day into 6-hour increments, that's going to give us 4 doses. So if the patient is to receive 800 milligrams per day, and we divide that evenly by 4 for doses, we would get 200 milligrams per dose. So you notice I'm using a little bit of dimensional analysis, and here I could have easily done dimensional analysis as well by multiplying by 1 over 4. But I can see here, and it helps me at least, to know that that 800 milligrams is being split into 4 equal pieces, 4 equal doses for 200 milligrams per dose. If you would allow me to write up above, I can write out the dimensional analysis. So we would have 100 milligrams per kilogram per day. We would multiply by the 8 kilograms. The kilograms would cancel. And then I'm trying to cancel out day, right? So I would cancel out day, and I would convert that into dose. And what I know is 1 day is going to be split into 4 doses. So if I multiplied the numerators, I would have 800. In the denominators, I would have 4. This would still result in the 200 milligrams per dose. So you can just use dimensional analysis straight across. If it helps you to kind of break it into pieces, you're welcome to do that as well. Notice the minimum here, the minimum safe range, is 200 milligrams for every dose. So it looks like if we're giving 300, that's at least above the minimum. What we need to check is that it's not too high. So what I'm going to do is I'm going to follow those same steps. I'm going to take the 200 milligrams. I'm going to first customize it for my patient. In other words, I'm going to get rid of that per kilogram. I don't want it to be just per kilogram. I want it to be for an 8 kilogram child. Notice if we were to stop right now, we would have the number of milligrams per day, but I don't want per day. I want to know how many milligrams this child is receiving per dose. So I want to cancel out day and go into dose. And I know, based on my calculation from before, if I'm giving this every 6 hours, that 1 day is being split into 4 doses. Notice here, day would cancel. My solution after converting would be milligrams per dose. I would have in the numerator 200 times 8, which is 1,600 milligrams. 1,600, excuse me. And that's being split into 4 equal doses. We're going to get 400 milligrams per dose. Just looking at this, we see here the safe range. Once it's customized for our patient, we see the safe range is between 200 milligrams for every dose up to 400 milligrams per dose. The order is 300 milligrams for every dose. So you would conclude, based on the recommended dosage of 100 to 200 milligrams per kilogram per day, this order would be appropriate for this child. The reason why? The order falls within the recommended dosage range once that dosage range is customized for an 8 kilogram child.